Another optimization problem for you. A farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? Is it going to be this case? Is it going to be this case? Or is it this case? So we're not just going to guess. We're going to apply calculus technique to find those dimensions. Our goal is to maximize the area A of a rectangular shape. So remember that the object can be illustrated this way. You have the river, X, and Y is the other side. And this is what you're trying to maximize the area here. But the formula for area has nothing to do with the missing side here. As long as you have X and Y, A is going to be the multiplication of X and Y. However, if you try to maximize this function, you need to get rid of one of these variables. You cannot have both X and Y present here. You just need one variable to take the derivative with respect to that variable. How to get rid of one of the variables? Well, we have the information about fencing, 2,400 feet of fencing. 1x plus 1y plus 1x equals to 2,400. So you can find the relation between x and y here and eventually write one of them in terms of another one. So since 2x plus y is equal to 2,400, y is 2,400 minus 2x. Now just take this expression and substitute it back in the area formula. A is x times y, or x times 2,400 minus 2x, which is, if you distribute x into parentheses, you get 2,400x minus 2x squared. Now what? You have a function in terms of x, which is denoted by a of x. 2,400x minus 2x squared, and x is bounded between 0 and 1,200. Now let's go to the next step and take the derivative of this function. We want to find the critical values. The derivative of a with respect to x, here you have a linear expression. The derivative becomes 2,400 minus the derivative of 2x squared becomes 4x. Set it equal to 0 and solve for x. X is 600. Very good. So what are you going to do? You're going to take the second derivative and check to see if it actually gives you a maximum value or not. The second derivative with respect to x is -4. When you have the second derivative negative, it means that you have concave downward object. It means that you get a maximum value at 600. You can graph this object and actually see at x equals to 600, you have the maximum value. So since x is 600, your y, which is 2,400 minus 2 times x, becomes 1,200. We found the dimension of the rectangular field with the maximum area.